We're going to do some practice problems from 5.2. These first two are like number 7 and 8 from the 5.2 assignment. We want theta to be an angle in standard position whose terminal side contains the point, and then we want to compute sine of theta and cosine of theta. Okay, let's plot this point -5, 8. Well, it's -5, 8, so about right there. The angle then that has the initial side on positive x-axis and the terminal side includes that point is going to look like that if we rotate it positive direction, and that's the angle theta. So dropping down to the x-axis, we get a right triangle. Because of that point, we can label the lengths of the sides of the triangle, and we have side of 5 here and side of 8. We just need to find the hypotenuse length. So using the Pythagorean theorem, hypotenuse is going to be the square root of the sides squared, the sum of the sides squared. So we get square root of 8 squared plus 5 squared, so 64 plus 25, and we'll get the square root of 89. Now the sine, okay, is going to be the opposite over, it's going to be y over the that radius length, which is the hypotenuse. So that is y is 8, positive 8, over the radius length of square root 89. And the cosine of theta is going to be x over that radius. Well, the radius, or the x value, is a -5, so that's a -5 over square root 89. All right, next one, we've got a point -2, -3. If we locate that point, if we plot that point, let's have it about right there. So the angle that's created with that on its terminal side is like that. And again, we're going to want sine theta and cosine theta. The angle created would be like that. Again, we need to find this hypotenuse. So the hypotenuse is equal to the square root of those sides, so 2 squared plus 3 squared. So we're going to get the square root of 13. Now we can write down sine, which that's third quadrant is that terminal side. Also, it comes from that point, which is a -3 for the y value. So -3 over square root 13, and cosine -2 over square root 13. All right, and these next problems, they're like number 1 and 2 from 5.2 assignment. We want to identify the two quadrants that theta could terminate in given the trig function values. Now really all we're really caring about here is whether we've got a positive or negative trig function value. Here we have a negative cosine, so cosine is less than 0. Well, cosine corresponds to x, so we're looking for the quadrants where cosine, or where x is negative. Well, that's going to be in the second quadrant and the third quadrant. So theta could have terminal side in either of those quadrants. So to answer that question, it's going to be 2 and 3, quadrants 2 and 3. Okay, for sine, equal to 4/7, it's positive. So we want to know, where is sine greater than 0? That corresponds to y. So which quadrants is y positive in? Well, in quadrant 1 and in quadrant 2, we've got positive y values. So 1 and 2. All right, tangent includes both x and y. So we have x over y here. So we have to take both of those into account. If we have, in the first quadrant, we're going to have x is positive, y is positive. So positive over positive is greater than 0. That's positive. So one of our answers for tangent theta equaling 1/3, theta could be in the first quadrant. Now in quadrant 2, y value is positive, but x value is negative. Well, that is less than 0. Positive over a negative is going to be negative. So that one is not going to be one of the quadrants that theta can have a terminal side in. In the third quadrant, y is negative, x is negative. So when negative over negative, well, that becomes positive. So that's another quadrant that theta could terminate in. In the fourth quadrant, we've got negative y over positive x. That's less than 0. So that one is not one that it could be. These problems are like number 3 and 4. We're given that sine theta is 3/10 and that theta terminates in quadrant 2. And we want to figure out cosine theta. So first let's draw this angle theta. It terminates in quadrant 2, right? We know that it has this point here corresponding to it. The sine theta is given to us as y/10, or 3/10. So that means we know that y is equal to 3. What we don't know is x. If we drop down a side here, we get our right triangle, and labeling the pieces that we know, the 3 goes on this height, all right? That's the y value. It's the difference from the x, x-axis. All right, and the 10 is the hypotenuse. Okay, so we can label that side as 10. So what we don't know, what we want to solve for, is this x. So solving for x using the Pythagorean theorem, it's going to be the square root of the hypotenuse squared minus the one side that we know, or y squared. So we get x equals the square root of 100 minus 9. So x is equal to the square root of 91. Because we are in the second quadrant, quadrant number 2, we know that x is negative. So we actually have a negative x value. So our cosine value is going to be negative square root 91 over our hypotenuse of 10. This time we have cosine equals negative 7/10, and theta terminates in quadrant 2. So we can sketch that angle like this. There is theta. The point that corresponds to it is, this time we know the x value. The x value is negative 7, and what we don't know is the y. Dropping down the side, we get our right triangle. So this value is y, that's what we don't know, but we know that the other side has length 7, and we know that the hypotenuse is 10. So to find what y is, using the Pythagorean theorem, we are going to take the hypotenuse squared minus the side we know, 7 squared. So 100 minus 49 underneath the square root, so we get y equal to the square root of 51. So that gives us sine theta equal to y over that hypotenuse. So that is the square root of 51 that we just found over the hypotenuse that's given to us of 10. Next one, we have sine theta is negative 3/7, and theta terminates in quadrant 4. Drawing that angle, here's our terminal side in quadrant 4. There's theta. We can label the point. We do not know x, but we know that y is 3. And if we drop, or we put a side to the x-axis, we get that right triangle, and we can label the hypotenuse as 7. So since we want to find cosine, we are going to solve for that x value, this unknown x value right here. But using Pythagorean theorem, we take 7 squared minus 3 squared. I guess I didn't label that. That 3 would go right here. So we get square root 49 minus 9. So x is equal to the square root of 40, and we can simplify that as square root 4 times square root 10, which will simplify as 2 square root 10. So now cosine theta is that x value that we just found, 2 square root 10 divided by the hypotenuse of 7. These last two are like number 5 and 6. If we have cosine equal to negative 1/4, and we know that theta is in between pi over 2 and pi. So basically it's saying that it's in quadrant 2. Then we're looking for sine theta. So if we draw the terminal side of this angle, right, it's going to look something like that. And because it's cosine, we know the x is a 1, and what we don't know is y. But we drop that side. We don't know this value of y, but we know that x is 1. That side has length of 1. And then we know that the hypotenuse has length of 4. So to find y, we use Pythagorean theorem. We're going to take the hypotenuse squared minus x squared, so we get 16 minus 1, so we get the square root of 15. So sine theta, all right, we're going to take y over that hypotenuse, and the y that we found is square root 15 over the hypotenuse of 4. Okay, we have the last one. We have sine theta is negative 1/2, and theta is in between pi and 3 pi over 2. So basically this is saying we have a angle that's in quadrant 3. So side is in quadrant 3, so there's theta, and we can identify that the point is going to have a, we don't know what x is, but we do know that y is negative 1, and if we create that right triangle, the hypotenuse is 2. So we know that this side has length of 1. What we don't know is this side has length of x, and that's what we need to find to be able to find the cosine, which is going to be x over that hypotenuse, which we know is 2. So we just need to solve for x. So using the Pythagorean theorem, x is the square root of hypotenuse squared minus that y value squared. So the square root of 4 minus 1, so x is equal to the square root of 3. So we can plug that in up here, and we get the cosine of theta is square root 3 over 2. But we do want to pay attention to the fact that we're in the third quadrant. And in the third quadrant, we have cosine being negative because x is negative. So this point actually is negative square root 3, negative 1. And cosine value is negative square root 3 over 2.